Hi, I'm Daniel. I'm a hardware engineer just like a lot of you. Spent a few decades designing circuit boards all the way from napkin sketch to the final production. I've worked a lot in design for manufacturing and new product introduction. So that means that I've spent a lot of time looking at the intricacies of how products are built, not just the actual design files themselves. So anyone who's been involved in the process knows why we're here. It's a time consuming, arduous, expensive process. And we as engineers, we want to design really cool things, but that doesn't always happen in a straightforward manner. Often there's a lot of hiccups along the way. So today we're going to be talking about Git for hardware, the pros and cons. This is part of the larger Git for hardware series. And we put together this book because a lot of people, a lot of other engineers, have questions about, do we really need to use Git? What other processes can be used to achieve the same thing? Or sometimes people have just heard of some of the productivity benefits that the software industry has created, and they want to get some of those, but they don't quite understand. And that's natural because Git is invisible. There's so many things about it that are valuable to you and save you time and energy, but you can't see it. There's not a user interface. You can't click on it. So there are user interfaces to Git, but we'll get there. So yeah, we put this guide together because a lot of people had a lot of questions. It's been the number one source of viewership on our site. So we took the book and we're now turning it into a video series for you, so that more people can have access to it. The world is the world's only going to get more efficient. Let's get started. Where do we come from? So legacy revision control. I don't know if some of you are old enough, but we used to actually tape out designs, and schematics actually used to be pencil drawings. And but yeah, we used to save files on hard drives and network files and floppy disks and USB drives. We still do that today. Um, and we would go from revision 1 to revision 1A to revision 1 October 17th. Revision 1, no, really, use this one. Um, and there was a lot of confusion. You could wind up sending the correct files, and then the contract manufacturer could wind up just going and grabbing an older email. So, we had really inaccurate ways of sharing the data. It was slow, it was prone to error. You could lose your files really easily. Um, so then we made improvements, started having things like network drives. And that's great because everyone can see one source of truth, but that also means that anyone can overwrite it. That anyone could, delete the files or put something that shouldn't be there. I think that's one of the most insidious things about network folders is an error in uncontrolled network files are often worse than not having design files. And if you've ever had to clean up a library, you'll know what I'm talking about. There's just like dozens to hundreds of just like small esoteric, like incorrect attributes. Yeah. So we have this problem managing changes, managing revisions, managing who did what, when did they do it, why did they do it. And we also have a problem executing. We could take a design and add a change to it, and the wrong file could wind up getting emailed to a contract manufacturer. So in comes product lifecycle management, or PLM. So this is software or process that allows you to say point to any individual group of files and say this is a revision. You're making this. These are the drill files. These are the XY files. Don't look anywhere else. And then you create an agreement and you limit the number of people who can communicate with the contract manufacturer to people who are going to deliver the correct file, the correct link. And you start limiting your contract manufacturers, start cutting off the people who aren't, make mistakes more than a few times. And so PLM helps us out a lot, but we still have things like a large monolithic review. So by that I mean it's 10 people in a room for 1 to 3 hours. Maybe it's split over a couple of days, and you're looking at the schematic, one page at a time, one subcircuit at a time. You're looking at the PCB, focusing on one area at a time. And everyone takes their turn, giving their opinion on what needs to change. Some of it's tracked. Sometimes it's an Excel spreadsheet. sometimes it's in an Excel spreadsheet, and you're able to write down some of the things that people are given, but you don't always track everything, and it's a huge amount of time at the end of a project. So basically, that review is you're combining things like, are these the correct files that we should send out with, is this design correct? And those are clearly different stages of the process, especially when you have lots and lots of designs. So even though the files are indexed in the PLM system, you still wind up having issues. Bombs could still be scattered across a bunch of different machines. If the source files disappeared or changed, you put something into the PLM system, and those files, the local files, could be deleted. The schematic files, and 3 months later, you go to do another revision. Where are the source files? Well, you didn't track them, or worse, somebody was messing around with them and added some things and didn't realize it because they're busy. That's where Git can come in. Git is not PLM. It can work with PLM. You can also use it to, I don't want to say replace PLM, but you can use it as like a small PLM system. If, for example, your team has a small number of part numbers, or a small number of boards, yeah, you can use it for a PLM. What you're really doing is just tracking individual parts, and so you can use Git to do that. But what Git is really, really strong at is the design work. Reviewing the designs and then making sure that every individual commit is what you want. So, segueing into that, one of the main reasons why we use Git is because of atomic commits. There's a lot of invisible things about Git, and there's a lot of things that are enforced by the software, and some of them are just convention. They're just things that you do. And one of the conventions that saves you a lot of time, money, and energy and quality, you get all three of that triangle, is atomic commits. It doesn't sound like much, so you're working in smaller chunks, big deal. So let's use the example of the monolith, the PLM review, where it's like 6 weeks of design, and then all of a sudden you're reviewing 6 weeks of design all the way at the end, compared to you at the beginning of the project, you select some components on day one, and on day two, or maybe after lunch, someone opens up the file, the changes that you said, and said, "Oh, you're using this line of parts. We don't use that line of parts anymore." So that's something that would have been 6 weeks before it could have possibly been reviewed, unless there was a preliminary review. So that's it's really powerful to be able to make your changes into smaller chunks. Naturally, you're not going to be saving every single thing. We're used to, I think everyone's used to, like, network Word documents where multiple people can be working on them at the same time. And that's great if what you're working on is a school project or a proposal. But if you're working on something like a pacemaker, or a vehicle, something that's saving someone's life, medical equipment, any of that stuff, you really can't have it's just like a network file but worse. So you have something that's too small of a change, like a shared work document, or just saving every time you put a single character on, or you move something a millimeter. What is the point of that? But you do want to have relatively small changes. And what I recommend is to group them together into like things. So if you're changing the power rail on a bunch of different components, you don't want to do it one at a time. You want to do it all together. If you're working on a microcontroller, change a bunch of pins on it, or you start routing things from it, then that's an atomic commit. Usually what I would do is, when you're jumping from one type of subcircuit to another, so going from an analog circuit to a digital circuit. But I think the best way is to talk amongst your team, figure out what's appropriate, what's too big, what's too small. You'll figure it out. But it's really, really nice to have these small little commits. The other part about it is, if you're doing that legacy long review, you get to the end, 6 weeks go by, and you're like, I'm gonna write my notes. I know everything that I did. I'm gonna write them all down precisely. And I'm sure you are good at that. And I'm sure all of your coworkers are good at that. But there's some people at some other companies building boards who they're going to forget a thing or two. So what's nice with atomic commits is you save early, you save often, and you take your mind, you're able to dump your thoughts then and there and say, this is what I'm doing. It also helps other people be able to track, to look at design decisions, to be able to understand more what your thinking is. Junior engineers can use it to learn. It's also a good opportunity to learn where your failings are. If maybe you're the person who's always putting the 1K resistor in with the 100K symbol. No, maybe you're doing it and you don't notice it, or you don't realize that you're doing it. So that's what these commits are for. So these atomic commits, they improve quality. They also encourage reuse. We love taking designs and like, oh, we're gonna take V1 and we're gonna turn it into V2. We're gonna just like take this part, just turn it into a module, and you've just doubled the time of the project, because if you're not good at modularizing things and reusing it, you're gonna hiccup on the execution. If you want to move something at the end of the design, you are going to have to rip up other parts and spend more time than it would take to lay it down correctly in the first place. It could take you twice as long to refit components in just to squeeze in a little bit. So, we have preliminary placement reviews, but what if you could have a review every single hour? Git encourages asynchronous design reviews. What does that mean? Well, like I said, we're all used to the monolithic review where a bunch of people are sitting in a room, but what is an asynchronous review? So Git has something that's called a pull request, and at AllSpice we call it a design review. What's wonderful about these things is you're working on two branches. Essentially, all of your changes are in the development branch, and you cannot merge them into your release branch, your main branch. You cannot release them until this design review is complete. What does that mean? Well, it means you have all the new files that you have. People are able to download them, or in our case, view them on the web viewer, and then go through them one page at a time, just like a traditional review, but they're able to do it all by themselves. And they can file an issue, they can message you if they have a particular question, they can take a screen grab. And what's nice about this is you're able to work at your own pace, instead of a bunch of people who in a room where maybe you might not say something because you don't know the most about power and there's a power expert in the room. Or maybe you have the firmware engineer in the final review and they don't need to be there for 3 hours because really all they're doing is evaluating 6 signals that have changed. Also, like I said earlier, it moves all of the changes earlier in the process. So what's wonderful about all of this is all these things add up. So freed up, you're able to use your time better when you have the energy. So instead of it being this arbitrary time, you can say, oh, you know what, I have a lot of energy, I'm really excited about reviewing this product. I got my coffee, I got my donut. Let's go. I'm going to spend the next 3 hours making those beautiful design review notes out of it. And it lets everyone work at their own pace. It lets you get experts to weigh in at just what they need to, so they can spend time doing other things. So everyone, it frees up an opportunity cost of time for everyone. As engineers, we understand the need to be able to track history. Just because you don't make a board anymore doesn't mean that you don't have a customer that doesn't have a question about it, or there isn't a new market that you can get into based on something you used to do. Parts go out of stock. I work for an unnamed company that discontinued an entire semiconductor line without telling anyone. Like today they're like, oops, oops, all shortages. I'm sure everyone remembers some of the part shortages of the past 2 decades. It's just total shocks to the system. So, there's a lot of different reasons to have your change history, especially if the system recovers and, all of a sudden you can go to cheaper components. You're like, well, what did we used to do? So if you're not tracking all of your individual changes, you're going to lose out on that opportunity. Also, there's some industries like aerospace and medical industries that, there's a compliance requirement to track your history and keep it somewhere. So, what a lot of our users do is they'll take their design reviews and their issues, and they'll just run a little script and then run an action and then export it to a PDF or export it to a zip file. And nobody opens it because it's compliance, but they freed up some time from having to create the compliance report. Now here's the most important part of that is if they make a change, because it's automated, they only have to do that small little work and change. That compliance report, bam, automatically generated. So other uses of total change histories, you can rewind to debug. So, sometimes you're like, man, where did this error come from? Or I'm sure your PCB files load 100% of the time, but I've had some before where you put something in there, you change an attribute in the software, it's like, I'm never going to load again. And it's really frustrating if the last time you saved was like 8 hours ago or longer. So being able to debug, it's not just is your design technically accurate? Working with ECAD tools, and they do very advanced things in mysterious and sometimes unpredictable ways. So, sometimes, a piece of software will inject bugs that you can't see. It'll load the design, but maybe it just overrode all the attributes. Or you implemented an ECO and you didn't mean to. And all of a sudden you just applied something to a whole bunch of things. And total history also helps you out with reaching the responsible engineer. Every commit, has a commit message, has a person related to it. I myself have forgotten that I've done designs that I worked on last year, but I once presented a design to someone, they hadn't worked on it in 20 years, and they're like, no, I never worked on that project. I don't know. I have no idea what you're talking about, and then you pull out the design and they're able to look at it, go, oh, okay, and then explain it. So, if you're able to keep more atomic commits than just that one schematic, you're able to explain things, and again, it frees up that engineer from having to remember that for 20 years. Who wants to do that? So project management is really important. There's a bunch of different ways to do it. Your process is your own way. It's your own way of doing things. So it better match how you and your team want to do it. And what I'm going to recommend is Git issues and milestones. So Git doesn't natively have issues. It's just a convention that we and other Git managed services have. And so what that means is they're just a bunch of database objects that track things like, change this trace, check the clearance between these two components. And they allow you to attach images and tag people. And what's really nice about this is there's a many-to-many relationship. So one issue could be on many different milestones. So you have a milestone that's like, we are going to release V2 of this board. And you could also have another milestone, V3, because there's compromises on designs. And sometimes you're like, let's do that next time. And so you could have that design, that issue on both of them. And if at some point you're like, oh, we can't do it on this, you have it on that other design. It's also like if you have like a module, or if you have something that's affecting a lot of different designs. We have 3 different layers of project management. We've got projects, milestones, and issues. And so projects can have as many milestones, and can have issues. It makes sense. Reasons that people like version control systems like Git is because it's very flexible. You can do what you want with it in the way that you want, and often in a very invisible kind of hands-off way. And one of the lightweight ways that you can manage things in Git is through branches. So if you've used SVN, you're familiar with branches. It's essentially, in AllSpice, we recommend a 2-branch strategy, a main branch and a develop branch. And your main branch is for all of your releases. Everything is 100% ready to ship, whether it's V1 or V2, which means that if you're doing design work and you're committing, often multiple times in a day, that work goes into the develop branch. So as you're doing the work, everyone else who's on the develop branch will say, oh, Daniel did some work on the develop branch. Let's pull it down and take a look at it. Or take a look at it in the web interface. But we can get a lot more fancier than that. There's something called Git flow, which is just a fancy way of saying separate branches for people and separate branches for features. Separate branches for separate people, separate branches for separate features. It's It's really intuitive. So if you're making a change, you create a branch with your name in it. If you're creating a change within a feature, you put your name and the name of the feature in there. So for me, the convention is, let's say we're changing, removing all the 10K resistors for reasons. Um, the branch name could be DD, those are my initials, DD underscore, um, uh, remove all 10K resistors, something like that. So another way of using branches, not just through your development work, is for tracking different versions. So um, there's a concept in Git called tagging, and it's essentially a named snapshot to any given snapshot in time. So you could do, for example, V1 is a good tag name, V2 another good tag name, but maybe you're doing something like prototype or first prototype, or you're doing a pilot build, or maybe you've got a customer who just needs a variation of 100 of a certain configuration, or maybe you got 10,000 duds in and you need to rework them all, and you want to capture that. That's where either creating separate branches or tagging can help you out with that. So no matter how you manage your flow, I'm sure you've got a chart somewhere with boxes and lines going somewhere. You can match that process, and once you dip your foot into branches, you're going to wonder why you never did it any other way. So another benefit of Git is that it's faster. Um, this is less important now with modern internet, but maybe you have a distributed team on different parts of the world, and maybe their server is fast for them and your server is fast for you. But when you try to work on each other's files, like they keep dropping. Um, it helps out with that. Basically, the way Git works is the first time you load it, you load everything. So yeah, it takes a while. But after that, you're only shipping and pulling the deltas. So if you've got a 100-page schematic and all you're doing is changing like one component, when you save that file, a very small portion of that file is going to change. So it's very quick to go up and down. The other nice part about that is locally, when you're switching branches, you basically are reconfiguring to different snapshots, and it can do it incredibly fast. Um, so it helps out with the design workflow. It's no longer like, oh, well, I'm going to start the syncing process and go get a cup of coffee. It's more like, I'm going to start the syncing process and, oh, it's done. I'm ready to work. Um, there are, caveats, like I've worked on gigantic files with their own center of gravity, and, they have their tidal forces on them. They're so big, and you need big spacers on, or sorry, big metal standoffs on them in order to keep them from flexing. So sometimes you have a really large board, and so what Git has done for this is they have something called Git LFS. It's Git Large File System. And that'll help you out when you're working with large files, or if for whatever reason you need video or some sort of binary file that changes a lot quickly. It's also helpful for mechanical engineers. A lot of people using SolidWorks or other large mechanical files find it's easier to track them in LFS for speed. Where does this all leave us? AllSpice is a company that is specific for Git for hardware. We do other things. Our focus is productivity and quality for engineers, but Git is one of the ways that we use that to deliver. And we offer managed Git hosting for your files. The big difference is for design reviews, we offer a visual diff, and the visual diffs are not just a picture. We're not just loading your schematic. We're actually opening up the project files, the schematic files, layout files, and regenerating the schematic and the PCB, so that you're able to zoom in, you're able to look at any given attribute. You don't need an ECAD tool to do this. You could send a file over to someone in planning, and they can open it up and take a look at a component and see that the part number is wrong or something like that. So these visual diffs allow you to make changes early. It's very intuitive to kind of take a look at the differences. But if you're not going to catch everything, just like in a design review. There's going to be some stragglers. There's going to be some things you're not getting into it just from looking at it. So that's where it jumps back to what I said about being object level data. So you can run automation on our AllSpice actions to automatically run your DRCs. Maybe you're a great person and maybe you always run your DRCs 100% of the time with all the warnings turned on. Maybe you're the sort of person who turns them off and forgets. This allows you to have a system where it doesn't matter what your personal workflow is, the system can run a DRC and say whether or not we're going to pre-order these components or not. Just because you added components to a design doesn't necessarily mean those are the ones you want to buy. So, there's no need to generate red lines. There's no need to, grab snapshots of things to show before and after. We automatically create that. And it's in an environment that allows you to easily create what we call snippets, to create snapshots of various, schematic or PCB elements. And these are actually hyperlinks that let you jump to where the issue is on that particular snapshot, on that commit. So everything is commit-based, and all the conversations are surrounded by the changes, and I cannot stress enough how important this is. We're going to go into this, I think, in another chapter, but being able to disentangle your conversation from email, from instant messaging, because when you look through there, if you look at any of your project keywords, you're going to find an unorganized mess. And yes, you will find what you're looking for, but it's not tied to a particular commit. So if you're looking at it, you're going to have to cross-reference the date. You're going to have to maybe do some math magic to figure out if it's the right file. But with this, the conversations are always local. One of the other powerful things about AllSpice is that we support multiple ECAD platforms. It's a modern world. There's a lot of distributed teams. There's also teams, companies acquire other teams, companies subcontract. There's millions of reasons why different teams might use different tools. So, sometimes, the design team will use, a very expensive piece of software, and then the test engineers will use free and open source software, which is fine. Maybe they're working with smaller designs or smaller boards, but we support all of that. So you're not really restricted. You're not in a silo. And what's also nice about that is it's unlimited reviewers. So, whether it's a technician or, junior engineer, you're not going to have to wait on a license. The system is designed for collaboration, so we encourage collaboration. We don't need around collaboration. So, well, that about wraps up this first chapter of Get for Hardware Guide. The things I want to really hit home are that Get reduces your overall effort, and make sure that the work that you're doing, the quality work that you want to do, you can get it into your files. Do it at, because you're doing it early and often, you're doing it at a lower cost and pulling in the schedule. So you really can have the triangle of quality, speed, and cost. You get to work asynchronously. You get to review with clarity, on your own times, on your own terms. You get to track every single change. Having a clear view in history. You get to collaborate with fewer meetings. I cannot stress how important it is. It just frees you up so much. Thank you so much for joining us. If you haven't already, I would like you to click the like, subscribe, notification bell, any of those things. If you have a question about AllSpice, or if you just have a really excited idea, drop down into the comments. I'd love to hear from you. We've got webinars, we've got ebooks, and we also have the next chapter of this video series coming up. So